All right, welcome everybody. I'm glad you could attend. We have a great session on tap for you here today, this morning, or it could be tonight, depending on where you are on this planet. We have a big group of ambassadors, over 400 now, which is just amazing. One of my favorite groups, of course, in Algorand. And we're going to be talking about basically new stuff today. We do have the goods up at this link on for the PowerPoint today's session. Okay, so problems with blockchains. In particular, some of you that may have been working with the Algorand blockchain for a while, say I have a long-running, public address, and then I want to change the authorized private key. Well, this has been a problem to date. You had to actually create a brand new account, and then you can use the brand new key that's paired with it. So that has some issues. And then number two, I have an account signing in my transactions, but I want to change it, to maybe a multi-sig. Maybe I've grown to a group, or even a logic sig as well. Maybe I've grown to the point where now I've got this programmatically, I want to sign this programmatically with a smart contract. So again, same kind of problem that you had in the first bullet point. It's difficult to do because you've been strongly paired between the private and the secret key, the private and public key. And then another one, I create a node and I can't use it for days, right? Catching up from the Genesis block takes forever. When I first did the very first hackathon I did with Jason that Algorand sponsored back up in Boston, we had people creating nodes, but man, they were at that time, it was only about 8 hours, but still that was a whole day, right, to do that. And now it's days. So this is a problem for people that want to get up and running quickly. So let's see what we can do to get that fixed up. And then, the cost and speed of other smart contracts typically make it difficult to, put in business models. The UX is spotty and it's tough to implement. A lot of problems with we've seen with other blockchains in particular on utilizing smart contracts and implementing them efficiently. And then how about searching the blockchain? How do I go about doing this and how do I do it quickly and get quick results? An example there, might be I create a game and I've got tokens in the game and I want to, that are, built with Algorand standard assets. And as a game developer, I want to build a leaderboard. So I want to know who has the most tokens, which accounts have the most tokens on the blockchain. That was very difficult to do not too long ago. And we also have some relief there and we'll share that as the session goes on. So our agenda for the next hour and 15 minutes is going to be, we're going to talk about some of the big growth Algorand has had. We got some layer one features we're going to kind of go through. So even if you're new, that this would be good for you with that section. Fast catch up is an area we're gonna show you some really big things happening, as well as rekeying that addresses the public and private pair bundling that we have right now and how do you get around it. We also got Indexer V2 for searching. We're going to show you some great searches and how to get hooked up with that very easily. We got some recaps here on the foundation reward programs. I want to make sure everybody knows about those. Lots of developer tools and community resources. So why Algorand? Once again, this is the main slide you want to present at any groups that you'd be presenting this to. It's a pure proof of stake consensus. If the crowd is brand new to pure proof of stake or to blockchain, you might want to go into a little bit more depth on the protocol, and we have slides in that in our prior sessions as well. But the idea here that you really want to emphasize, it's a very efficient and modern blockchain. It scales to billions of users. Always stress the transaction per seconds is less than 5 seconds block times. And we are actually working on that to really even make that a higher throughput. Instant finality, there are no soft forks, and it's very cost effective, less than 0.001 cents basically cost per transaction is just 1/10 of a penny. So that is pretty good. All of those really lend themselves to a lot of people that want to build solutions now on the Algorand blockchain. And speaking of which, man, look at this list. So we got a ton of folks now that are really engaged with the Algorand blockchain. all from the technical side, financial infrastructure, and there's a nice ecosystem of applications that are now being built as well. Things like Asset Block, where we parse out, assets of, to multiple shareholders. You got up on the technical end, we got some really great explorers out there: Algo Explorer, Goal Seeker, TEAL, Algorand Builder, Algo Signer. I'm going to show that today. Algorand Studio. I mean, this community is thriving. Let me tell you, it is really, really building. We're on track for 10 million users, on chain by end of the year, estimating over 1 million transactions per day by the end of the year. The growth has been phenomenal. Year one, right? We went mainnet last year ago, June, and we've got over 400 companies now leveraging Algorand's platform. We're one of 2 blockchains with 2 stable coins. And that's a very important point, because this is really a key differentiator with other blockchains when you go into present it to your group. So USDC and USDT, both of those. The other one for your reference is Ethereum. So it's just us and Ethereum on that particular bullet point. The ambassador group, man, you guys rock. We're over 400 ambassadors now. I got to update this slide. And then 50 plus wallet providers. We got over 500 nodes globally, and the list goes on. So success is the bottom line there. So let's get into the Algorand layer 1 features. All right, we've got Algorand accounts we're going to talk about. We're going to talk about rekeying. Also Algorand standard assets, atomic transactions, and Algorand smart contracts. So this is really the core set, right, of information you pretty much want to have in every deck and every presentation that you do. And the Algorand accounts, let's start with this. So basically what you see here is you got a standard account, and notice there's 2 keys kind of penciled in there. One of those is the secret key, and one of those is the public key. And then you have a multi-sig account where you have basically a threshold. So say you got 3 in this picture here in the middle, 2 of them are going to be required to sign off on any transaction. So it's kind of like, analogous to going to a bank and getting 2 signatures on a check in order to be able to cash that particular check. So, and then finally now we got a logic account, right, which is a smart contract. Well, the account part of this, really, way you can think of this is who's got signing permissions, right, to send digital assets or digital currency, out. So that is really the key thing there. Really what this equates to is who does the signing. And so with rekeying accounts, I did a snapshot, by the way. This is now supported in the Algorand wallet here on the left. What you have here is a public address, which is, the authorization. And then you also have, smart keys that are behind it, right, that you can rekey to have it signed by another account or by a multi-sig account or by a smart contract. To further expand upon this, basically, for those that are brand new to Algorand, there's a few of you that are listening here. These combined, the public and private key combined, is a cryptographic key pair for an account, and the public key forms your identity, and this is what's used as the address when you receive, digital assets. The private key is held in a digital wallet, like you saw me show on the prior slide. Your wallet uses it to approve transactions, right? You want to keep that safe, right? So approve transactions sent from you. That's the important thing. So wallets are really no more than a collection of private keys. All right, an account attribute is the authorized address to send the transaction. So initially, this matches the account address. So you can see the pair of keys on the left image on the bottom. Now, rekeying allows you to decouple this, all right, in the private and public key and assign another authorized address to approve the transactions. So the second image there from the left is the orange and yellow key are separated, they're decoupled, and then you could take this same account that's faced out publicly, right, the public address, and then you can use a different signing for either another individual or a multi-sig, or on the far right, in the case, that's an example of going to a smart contract. Now we'll get to the ASA, right? Algorand standard assets again. Issue layer 1 native token. So it's like native, like it's native. It's right on layer 1 of like an algo is, and it has the same benefits as an algo. You prevent doing transactions when there's not enough in your account, for example. It eliminates double spend, all that kind of stuff. Very easy to create. Create in minutes. I'll be showing you that as a demo in a little bit with AlgoDesk. There's some visual tools out there that can create these. And then an administrator can mint and burn units and freeze accounts and revoke assets and delegate, all that good stuff. So a lot of management capabilities. And also it has asset spam protection. So accounts have to opt in to transact with the ASA or the account. All right. And then you get the atomic transfers once again. So this is where you kind of group tasks together and they all must succeed or everything will get rolled back. Very analogous to a SQL Server transaction for those who know SQL Server. And in the example here, you got person A sending 50 algos to person B. Person B then issues a concert ticket to person A. And this is, null and void if person B doesn't issue the concert ticket. It just rolls right back. Both of these things have to occur to make this get written out to the blockchain. So this really is a good benefit, especially when you're dealing with folks that you don't, necessarily trust or know. I can't tell you how many times I've heard somebody get burned, like on Craigslist, that they go to buy tickets and they got scammed, and there's really not much you can do ahead of time to kind of prevent that. At least you got a good, fallback here for that type of a scenario. Smart contracts. So now we got transaction execution language or approval language. That's called TEAL. And that's what the smart contracts are written in. There is also a Python enabled compiler, PyTeal. It'd help you generate the TEAL. Now, there's two types of smart contracts now. Stateless is what we had from, I think, November when we introduced Algorand smart contracts. And now Stateful, which provides on-chain global and local storage. And we got a demo to show you that here today as well from the SDK code. The stateless one is used to approve spending transactions. So that can be done either by account or by delegation to have, either the contract return true or false for the account version, and then also delegated, you can, in addition to that, have a signer on the account as well to issue it. Now, these are all combinable with other Algorand technologies, right? Atomic transfers, Algorand assets. You can also combine stateless and stateful contracts together. And a little bit more here on TEAL. Basically, it's a bytecode-based stacked language that returns true or false. Positive value left on the stack, right? And then you have SDK support. There's like over 90 opcodes now. You have access in TEAL to ASA and to algo balances. You can read all transactions in a group for the atomic transfers, and then also you get stateful with global and local storage calls, and stateless with signature verification, and then the PyTeal like we mentioned. So here's an example. So we got basically a transaction. We're going to pop onto the stack, a close remainder to, and then convert the address to byte constant and push to the stack. And then you want to pop the two values off the stack and replace with a 1 or a 0 depending if they were equal. And then also you can see here, the Python library, PyTeal, up in the upper left corner. This is the code that will generate, the code that's in the bottom right. Great video on TEAL. Those want to learn more. One of our engineers did this, really excellent job. So once again, this is in the deck you download. You can go ahead and view that as a homework assignment. All right, now Algorand stateless smart contracts. So this is new. Like stateless contracts are not new. This was what we had originally. So it replaces signing of transactions that you would normally have done by either an account or a multi-sig. There's two usage modes. The logic account, where any transaction sent to this account will be verified by the predefined logic. So again, that's just pure logic in the contract that identifies whether this gets signed or not. These are great for ESCO style accounts, split payments, and hash time lock contracts. Then you also have logic signatures. So any transaction signed with this signature will be verified by the predefined logic, or in other words, a delegated authority. This is very useful for solutions such as recurring payments. And stateful smart contracts, once again, this is where you basically application call transactions will trigger, a smart contract. And the smart contract then can increment the global state as needed on the blockchain, or local state on a per user basis that you see on the right. All right, and now we get into some solutions, right, that you can build and start combining a lot of the stuff together. What we have is combining layer one features. We have an example here where you got a voting commission account that will have a spend voting token, and then the vote will be cast for candidate A, and then you got a voting smart contract then that will increment a total vote in global state, right? Because you want this globally accessible in terms of the number of votes that you have for the various candidates. And so that's combining some layer one features on that, right? So you've got the another example here is in a crowdfunding escrow account where you have a stateless smart contract up on the top, where you have a payment from escrow for user one, and then if the goal is met in the crowdfunding, user one claims the escrow funds through a smart stateful smart contract. So good, an example there of using stateful and stateless together to be able to do that. Now, both of these are solutions that are written up on the developer portal. Just go under the solutions section and you can see the details on each one of these for building crowdfunding applications and voting apps. Next topic, Indexer V2, one of my favorites. It really comes to life, in my opinion, the usefulness of the Algorand blockchain. You really want to be able to query it, right? You want to be able to get information off of the blockchain. Now, the way it works is it doesn't actually reside right on the blockchain, because that would really be weighing down the blockchain. The same reason we don't actually put VMs, on the blockchain because it's very, very heavy. And instead, we will offload an algo process and then provide an indexer that you can populate into a Postgres SQL database. Also, there is a indexer V2 REST API, and as such, it's also built into all the SDKs to be able to access it. This is really great stuff. Now, to build your own, what you would see here is a very lengthy process to do that. So you can, other benefits, with the Indexer V2 is you can search on transactions, accounts, and assets, and these are all searchable in index. So search filters on the round, the date, the address, balances, signature type, transaction type, asset holdings. And then also you can look up historical account data for a particular round even. And also the results provide pagination. It's enriched transaction and account data, confirmed round, block containing of this transaction, which is just awesome. You have a confirmation time. You can look up signature type, asset IDs, close amount when applicable, rewards. So these are all available. So as I mentioned, you can build your own. There is a link on how to do so. This will take at last take days, depending on the size of the blockchain, or you can use a service. There's a one by PureStake, and actually that's what I have all the code curling up to. Understand Rand Labs is also working on one too, and so there might be more down the road. So these are things you can look into and start utilizing instantly, and or you can build your own. So those are the two types of choices that you would have. Oh boy, fast catch up. One of my favorites. Once again, the problem here is catching up from the Genesis block, and this extends the time to productivity. Nodes create catch points, so a secure and downloadable ledger of this of specific blocks are done. And really, the only catch up time you got is between the snapshot and the current block that's being built. So that's typically under 10,000 blocks. It's got a update, which is, basically minutes we're looking at as opposed to days, in a prior life. So we heard you loud and clear, and this is a great way to funnel feedback is through our DevRel team. Feel free to do that. All right, rekeying. Basically, this is the problem here, like we had alluded to before, the private key security policies without operational overhead. And to change a signing key for the account, you have to create a new account. So again, they were strongly coupled. Now we decouple them. And so basically you can change it to change the authorized private key as desired. And what you'll now see in the rekeyed account is an authorized address pointing to another account. And that address could be an individual, it could be the address of a multi-sig, or it could be the address of a smart contract. But that's what you'll see when you do a look at the data coming back from the response for the account. It's very simple, right? Single optional new field in existing transactions, and that's it. And it's flexible. You can change to a single key, like I said, a multi-sig key or a stateless smart contract. It's unlimited too. You can change your authorized private keys as frequently as desired, providing really maximum flexibility there as well. Algorand Foundation Rewards Program we got here is next up, and this is just a good recap of all the reward program links that we have available to ambassadors, and some of them are even for non-ambassadors that you would see here. We've got the Developer Awards Program on top. The DevAms reward in the second one there, that's a good way to get into be an ambassador program. You can share that with your ambassador to bees out there. You write up a tutorial or a solution, and you'll get that posted up onto the developer site. Grant programs are becoming more and more popular. Also, we have ambassador rewards programs for helping out. I know I got a few ambassadors that are helping out with the Q&A here today. Stevie and DDev, we got you all hooked up here so you guys can put in for helping out, in the program. All right, so developer tools. Man, we got a ton now, and I'm just loving working here because this list keeps growing and growing and growing. We've got, SDKs, in the four major languages there: JavaScript, Python, Java, Golang. CLI tools from Goal, Sandbox. If you haven't used that and you're a developer, man, check it out. It's really great for quick setup. You can switch between, BetaNet, TestNet, MainNet very easily. Would not use it for production use though, because as soon as you close Sandbox, everything goes away that you did, in terms of anything local on your machine. Like if you did, writing of a transaction out to a file, right, for offline use and testing that out, that'll be gone the next time you do a clean. And then Indexer V2, REST API for querying blocks in the blockchain. We got the wallets now for Android and iOS. Algo Signer just came out this week, a Chrome plugin for signing transactions. Is that cool? Kind of a MetaMask, answer for Algorand. And then community supplied things, Explorers, API services, SDKs. We're going to show you a lot of this stuff. There's the link for the Chrome extension for Algo Signer. And you can see a snapshot of some stuff I was doing last night. You can set it up for testnet. You can see up there in the upper right. So you can feel free to use fake algos and this is part of the process, as you can do in the Algorand wallet. You can set that up. There's a switch in settings to go to testnet. This is a great developer newsletter. Once again, this is where we're having our little contest today to receive an Amazon gift card at the end of the session. Encourage you all to sign up for this great newsletter. Liz just does a bang up job on this every week. And you know what? There's a lot of great new content every week. So you'll stay in the know by signing up for this newsletter, whether you are a developer or not. This is really a great read. All right, for the basic folks, once again, we've got these three networks, the test and mainnet. are always mirrored each other. Beta net is where you get the experimental stuff coming in, maybe do protocol upgrades. And then the private network is kind of like, I view as like a personal network. And I like a good use case in that with beta net, where you want to keep a stable environment and avoid these, very consistent upgrades in beta net, and, knock your testing out. So that's kind of like what I like to use that for. All right, so the Open REST V2 specifications, we have moved to the Open API specifications, or OAS, and we have 2 versions out there, version 2 and version 3. I think they all work except for the indexer on the very bottom. The 3 seems to be currently giving an error, but basically you go out to these locations in the repositories, GitHub repositories, that go Algorand for the AlgoD, and then the indexer has its own repository under Algorand. So there is a file there. I'm going to be updating the site with these links in it. Right now, you do have this slide deck as well, so you can either just clone those repositories, and you'll find them under the AlgoD API section, or on the bottom, the Develop API section for indexer. You got some really great to create nodes. Once again, you can create your own, and now you got fast catch-up. You can use other services like PureStake and the Sandbox Docker that runs in all environments, including Windows. So no sync time as well on that one. That's an example of how to run that. Great documentation. Once again, you can see here we've got a just constant updates to the developer site. This is a great slide to show developers that are just starting out. You want them to go to the Start Building section on our docs, and to create the workspace, connect to a node, and do your first transaction. At least those 2. We added a new one there on building applications. Ryan put that together, and Jason, and that's all about smart contracts. So great resource to point out right there for anybody that's getting new. They ask you, where do I start? Well, that's the place. And then Lookup Solutions is the one I just posted the other day. I talked about the C#.NET SDK, where we have a sample solution now for building mobile applications across the board for iOS, Android, and UWP for Windows. Also, you can see an example there of the voting Stateful smart contract application under Solutions. A lot of great articles. Another good one to point new folks to is this Getting Started on Algorand article that I wrote a few months back. Tutorials, step-by-step instructions, and all the tutorials have links at the bottom for code, as do the features. So that's a very important resource to point out as well to anybody you're presenting to. And again, ambassadors, great group. Anybody that wants to become one, have them send an email to Stefan at Algorand Foundation. And these are the links for if you wanted to post a blog to the community blog, just email it to ecosystem@algorand.com. And always also let them know about events that you're doing, and we'll post them up on the events for the community as well. This is the C# SDK. That's a community SDK. We're looking to upgrade that as well to V2. Right now, it's got all the V1 features. Code demos.
Can you see my screen? Russ, can you see my screen?
Yes.
Okay.
Yes.
By the way, let me minimize this stuff real quick. Just so you know, this is the someone asked her about Algorand Studio. This is where it's located. Okay, so I'm just going to show something real quick and talk a little bit about one thing, if you've written any TEAL programs up to this point, whether you've done it in PyTeal or just written it directly TEAL, you understand that it's kind of difficult to debug. So what I'm going to show is we have a new debugger, and it'll be available in the next set of binary downloads. Once we do one, we're expecting an update real soon where we just update some of the binaries, and this one will let you download something called TEAL Debug, and I'm gonna show you what this looks like. So the way I'm working with is this program called, I'm working with a TEAL program called program.teal. It's actually this one right here, your first application, located under Stateful Smart Contracts, your first application. And this is one Ryan wrote that lets you, all it does is increment a global state variable. That's all it does. All right, so if I go into my program, this is pretty much it. All right, if I want it, I've already got this one. I have a private network up and running, and I've already created the application using this script right here called create. And all this does is right here is creates the app right here. This is the goal command, and then this is just goal app create, specifying the creator, the approval program, program TEAL, how much global state I'm using, which is just one global integer, and then the clear program. Okay, those are the two programs associated with a stateful smart contract. So this one's already created and running. So now if I make this, I got another shell script that's all it's doing is making a application call to this. And this app ID is the app ID returned when I created the smart contract. Now this obviously is not going to be one in your case. It'll be whatever the create call returns. And then I'm going to pass an argument to this just for testing purposes from what account. And here's the trick: is I'm going to, instead of letting it send directly to the network, I'm going to write it out to a file. And if I specify this dry run dump here, it actually formats this with all the data needed to set the context for the debugger. And what I mean by context are things like what transactions are being used, what accounts are being referenced, so I can pull the balance records out of the ledger. All of that is dumped into that dump DR file. All right, and then I can run the TEAL debug program to debug that dump file. So the way this works is if I just make this call, you'll see that it opens up a listener for the Chrome debugger tools to connect to. By the way, if you wanted to look at that dump file, this is what it looks like. So it's got all the data in it that's being used. You can also put that out in message pack format if you want. But then all you got to do is go to Chrome, and you type in Chrome. All you have to do is type in Chrome : / inspect, and you'll see that there's this little inspect link here. If I click this inspect link, it fires up the Chrome debugger. And you can see this is my debugger. Here's that program, the TEAL program you saw me looking at. You can set breakpoints. You can single step through the code, set watches. But the primary panel you're going to be interested in is probably the scope panel. Now what this has is it has my global data associated with this smart contract. Right now the counter's up to 4. It's just a number that's being incremented. And then this, if you have multiple transactions, like you're doing atomic transfers, this will have every transaction in it. This is the current transaction that we're running. All right, so there's all the data associated with that transaction. Then we have the scratch space if you're writing to the scratch space. But the stack one is most important because what most people have an issue with is they end up returning with too much data on the stack. If you have anything other than one positive value at the end of the program, then the call is going to fail. So this is a great way of just walking through it and seeing. So for example, in this particular case, I'm going to load a transaction type enum. So I'm trying to figure out what type of transaction this is on the stack. When I do that command, you'll see the stack has a value of 6 on it. So that's the enumerated number that represents the type of transaction, which happens to be an application call. And so I can check this by loading int APPL, which is the enumeration, and those will be equal or not. This happens to be an application call, so it goes through. If I click the next one again, it checks those equal, and it removes both of those off the stack and puts a 0 or 1. Now BZ is a branch statement. It says if it's false, jump to test. And if you look down here, test just loads int1 on the stack and returns, meaning the call fails. But in this case, it's not. If it was B and Z, then it would be testing for a true. So in this case, it's not going to do the branch, and then it's going to go through the rest of the code. Now I won't bore you with all the details on that, but if I hit play, you can see it goes to my breakpoints, and it runs through, and you can actually single step through all the code and make sure that your smart contract at the end. So if I just play this to here, when I get it just returned there, I should have checked that, but you saw my counter was there. I had 1 left in the stack, and its value was 5. All right, so that is, and if you got to remember, anytime you have global state, if the call returns a failure, even if you've incremented the global state, the global state increment will be rolled back, so it won't count. All right, so then when I play this out, I can then just close the tools. This will shut down, and you can see that now it's set down. We also have a web front end that you can play with too. And the cool thing is this works for both stateless and stateful smart contracts. So I wanted you to be aware of that. So this is technically, you can build this today in the source, but it'll be in the binary downloads in the next update. So that's pretty much all I wanted to show on that.
Well, that is awesome. Here is the AlgoDesk screen, and I'm going to go ahead and click on Asset Management. And this is going to automatically create an account for you, and this is how you're going to be able to restore that account. So you want to copy that off and put that somewhere. And then let's go ahead and get started. And then what we can see here is I'm going to go ahead and create an asset. And let's call this Russ. Today is 9/2. Okay. And then unit name. Let's give this thing 9/2. And then you got total supply. Let's do 10,000. Let's do it at decimals, would be 1. So this means there's actually 1,000.0 of these units that are available. We can go ahead and put in a URL and then set the defaults basically on everything else. And then you can see this is the address that was actually created that mnemonic ties to for reserve address, clawback, freeze, and manages. So a lot of these you probably won't use on a day-to-day basis. Most of you would just use this to transact from and to. But if you are creating, an application, you want to create an asset, this is a very easy way to do that. You would actually see it on the list here right at the end, for that particular asset created. And then so that's the AlgoDesk IO, and then also that is where you can see you can look up the Algorand, the TEAL. There's a TEAL editor there as well that provided. So great community stuff here, and hats off to folks that actually developed that. I'm going to also show you now. Up here is the Chrome plugin. You can see right here, and I've got it wired to testnet, and I have an account, for example, and it lists the transactions that I've done. You can, load more if you want and see everything that's going on there. And what I'm going to do here is just do a live transaction on this to show you how easy it is. So I've got an account here. I'm going to go ahead and paste this in the send algo. So we're going to hit send. We're going to say the amount of algos we're going to send, let's say would be like 5 algos, and we're going to go to this address, and this is going to be demo ambassadors. Okay, and then we got here, it even's got spell check in there. How about that? But it's not working. So that must be the browser support. So anyway, you get the idea. I'm going to go ahead and send this, and go ahead and put in my password. It will not let me type in there. I don't know why. Oh, there it is, back to account. So it's sent. All right, so it took my password and it did, and there's the transaction ID. I could copy this off and go back to my account, and there you can see the 5 algos were sent, and I can actually come up and look at, one of the explorers, look up that transaction. This is going to testnet as well. And now you can see the transaction. So very easy to install. It will ask you if you already have a wallet. If you got an Algorand wallet, it'll go ahead and you put in your account, and it'll wire it up like I did. And then you can also switch between networks from testnet to mainnet as well. So that was the 5 algos we just sent. So, and there's the it did fix the spell check. It just didn't show in the IDE, so that's pretty good. We're all learning together here on this one. All right, and the crowd goes wild. So then next up, we're going to go take a look at a stateful smart contract in TEAL, written in TEAL, and we'll show you how to do this through a Python example using the SDK functions that are built in. So I'm going to go ahead and bring this up big, and we're going to go right to the top here, kind of show you what's in it. We got a creator account we're going to have, and we're going to have a user account. So the user account is where we're going to be storing local storage, and then the creator account is going to be doing the signing. And what we did for ease of understanding here is we actually put the program in line. When you go to do this, you can read in the file and then not necessarily have it right in the code, but we felt it was good for optimization. And hats off to Ryan who wrote this particular example. And then what we're going to do is you want to do the opt-in first of all here, and then also you want to initialize some of the labels that we're going to be potentially going to, and then you get down to the addresses, right? This is the creator address that corresponds to this creator mnemonic, that we're reading in. So if you're doing this, at home and you want to replicate this, you'll have to copy that actual address in the TEAL. Then you can see what we're doing here. We're going to read the global state. We're going to call this app global get, and then we're going to increment the counter there and then store it with the app global put. And then we get down to the next level as well. Then you have the increment value here for the local state. So again, you got a pair of ops that will go ahead and get it and then put it. And we're going to go ahead and increment those. And that's pretty much it. It will go ahead and do that. And then there is a second program called Refactored, which is basically the same as the first one. We want to show in this code how you update a contract. And the only difference in this one is it will take an argument for the timestamp. And just this section right here is really the only difference between those two programs. And I'm going to go right down. I've got my breakpoint set. You can see, oh yeah, I want to point this at now. There's a compile function now available on the SDK client, so you can take the source and then compile it right in stream in your application. Very, very cool. And here's a routine to create a application. I'm going to actually set a breakpoint on that one so we can see that coming in and executing when I call it. So I'm going to go to the main line down here. These are all routines. So the main line, just to kind of show where we're going here, we're going to create an app. We're going to opt into the application, and we're going to call it. We're going to read the local state, read the global state. Then we're going to update the app, all right, with the oh yeah, there's an approval program that was right at the end of that. Let's go ahead and run this, and we'll stop at the breakpoint. So yeah, there was a simple clear program up at the top too. It's just, I think, an int1 on there. So the first thing we're going to do is declare our application state in storage. We're going to go ahead then and create the application ID. So we're going to pass it the private key for the creator. We're going to pass the approval program, and then the clear program was the int0, and then our global structure, right? So if I go ahead and hit the go, now we'll hit the application create transaction, which is actually going to create the application. And then the usual, right? We're going to sign the transaction, we're going to send it and broadcast it out, and then confirm it. So those are the 3 steps involved pretty much in every transaction. So I'm just going to hit run, and we're going to see the output down below. I'm going to maximize this so we can all see this a lot easier, as well as this window down here. So the next thing we want to do is go ahead and opt in, and you can see the transaction. Here's the app ID in the very bottom of the screen that got generated as well, which you see passed into this. So this is going to take our user's private key now. So the user is going to be able to opt in to utilize this particular application. So again, that prevents the spam. And there is the transaction that does it, the application opt-in. And so again, we're going to go ahead and see the confirmation appear at the very bottom of the screen, and there is the account number also listed in the app. So now we're going to call this application without arguments. Arguments would be the last parameter here in this particular routine, and it's going to go ahead and call this application with the that information, and then we're going to read from a local state. And so when I read from local state, then you can see here, I'm going to go ahead and print off the local state key value, which you can see up above here for in the debugger, right? And there is the key, the length and functions and all that stuff are in there. And now I'm going to go ahead and continue this and then do the read and display the information down below like you see. And now the global state is next, right? So now we're going to go ahead and pick the global state. So this first piece of information down here is for the user. And then down below is the, we're going to see now the information for the global storage actually specified. And then the approval program, we're going to go ahead now and load in that refactored one. And once that's done, again, we're going to call the application update method there on that one. And then we're going to go ahead and call this with the timestamp parameter that we are needed now as an argument. So as soon as this completes, we'll come back to the app. Again, we're going to go ahead and read the local state as well. And so once again, and then we're going to close out the app from the application using the user's private key. And so, and there's the closeout function that you would be calling for doing that. Okay, so now what we're doing is we're basically maintaining two counters down below, and you can see one, for the global, two for the local storage, and then you can also see the opt-in again for this particular call for the user to participate. And then we should also see the timestamp being passed in as a parameter. So now we're back here to the main line. We're going to call the app. This time we're going to pass in the arguments for the date parameter that we've loaded up above, and it's going to call that application, and then we're going to go ahead and do the same thing. We're going to go ahead and read the local state for that particular function, and we'll see this information get updated down below for the local state as well. All right, and then finally, we'll get done here. We're going to delete the app, and I think there is a limit of 10 apps per account, and then you can see the information going out below, and it's been deleted. And then finally, we're going to call the clear app, which is that tiny program we had up above, and we're going to go ahead and clear it. So that's the clear state function that you have there. So that was probably a good idea of a lot of the types of transactions that you would need, from a programmatic perspective that are available in the SDK. Well, I'll show you one more smart contract example. This is the stateless version, and this is a contract account. So what we're going to do here is pass an argument in. So let me just, I think I got my breakpoint set. I do. So let me just run this. And I'll explain the code here when we get to that breakpoint. So the first thing we're going to do is load in the program. So this one actually reads in the program, okay, that we have sitting out on, the project root here, the sample TEAL arg. And all this does is put in, it's got 4 lines of code, right? So I've got my argument, and I'm going to compare it to the value 1, 2, 3. If it's equal, it's going to return true. And so this is going to be the argument that we're going to pass. So the next step is indeed to set up the argument, which we have right here. So now we're going to add this particular argument in. The value is going to be 1, 2, 3. We're going to call logic sig with the program that we read in, as well as the parameter that we're loading in. This is going to give us an lsig value. If I go ahead and pop over this, you can see the information as well with that particular lsig. And then we're going to send this sender, if I go over the top of this, to the lsig address. So that's actually an address field now that's going to be doing the sending. And it is signed, it'll be signed, by this logic sig right here that's doing the signing for that particular program. And then finally, we're going to do the payment transaction. So the sender we have there, and then the receiver is going to be the second account, right, that we're going to be sending this to. And that's it. And then we just go ahead and fire this up, and then you can see you've got the logic sig transaction. We're going to create that with the contract account lsig transaction, and then we're going to send the raw transaction out to the network, and you should see a successful run there down below. And then finally, on the smart contracts was the account delegation, which is basically the same, except for we are going to have an account do the signing. So this is where we're going to get the secret key from that particular account. And then we're going to sign the lsig with that particular account. So that is what gets sent in, is that user address for the signing, which also contains the lsig as part of that right there. All right, so that's it for that one. So those are our stateless demos. And then another thing we're going to show you now is we'll talk about the REST API a little bit, and the site here I want to show you first. This is a great site to get started on our docs. It's the API V2 migration guide. Ryan wrote this. Thanks a lot, Ryan. Hats off to you on this one. I use this page all the time. First of all, this shows you how to update your SDK. So you always want to be the latest version. I think we're up to 1.7 on the JavaScript SDK. And then also it shows you, the V2 version here is exactly the same for the Algorand. Indexer is not available in V1, so this is what you still would require to get the SDK loaded in. And then the useful thing is to have the client instantiations. How do you invoke the client? And so this is how you get started, folks, right here. And then you have the same thing for the indexer. Then you got the same information for Python and for Java and for Go. So great resource right there. Then also what you can do then is take an example here where I'm going to show you. I've downloaded some of those definition files, and I know a lot of the developers that I talk to a lot will also want to utilize a tool, to do development with. So a lot of times what you can do is use something like Postman or Paw to do that. And one really nice thing you can do here is you can import those definition files. So I'm just going to drag this over here into this. This is going to create a folder called Algo REST API dot. We'll go ahead and import this. And then what you'll see down below is the actual import that gets done on your behalf. So there's the new one we just downloaded. And what's nice about this is it provides all of the paths right here. And then this base URL you can set up in the properties for this particular collection. You can go edit it. And then over here on the variables, you can put in localhost and then maybe your port number for like the sandbox, for example. And then you got that done. And the only other thing you would need to do is populate, for example, the header with your token, the Algo API token, which is all A's for the sandbox. And then you can see the params here for this one's got an address field. This address key is already in there, and you just put in the particular address, you hit send, and boom, you get back your data. I'd love to get it working in here first. Anytime I'm using a new API and an SDK, this way I know if it's not working, it's something I'm doing wrong in calling this API. It's not something necessarily wrong in the program, that in my code, and that eliminates a problem. Also, if you have a dispersed team of many different skills. One time I was on a JavaScript, Java heavy team, and I was doing a C# version of the app. I really couldn't show them my C# snippet to get them to help me if there was a problem. I would say, okay, here's the screenshots from Postman, here's what's going on. So anyway, a great tool to leverage there. I use it all the time myself. And or you can use curl commands, of course, from command line prop to invoke these APIs as well. So all right, so fast catch up. Basically, again, this is up on our site. Very good. Very easy to do. This is under our setup where you set up a node. So here I'm going to click on this testnet, and then you have links there for testnet and for betanet and mainnet. So I'm going to copy this, and basically all you got to do is I'm going to bring up my the sandbox, which has the goal in it, and all right, and so all you would need to do here is to do this, and then you would just paste in that that item. Now you can see right now I'm already caught up. Sandbox is already caught up. But if I had a brand new node, I would hit that, and then you can also do a just a status. And when the sync time gets less than when it gets equal to 0, you're all caught up, and literally that will take just a few minutes. And I was ecstatic when I was actually writing the demo that's on that particular page you looked at, and you can actually see some really solid results right away. So no more wait times for getting caught up. And the last demo here, I'm going to show you this indexer here. So I'm going to show this in actually JavaScript, because I know we got some JavaScript developers in here as well. So we'll just start out. This is going to be wired up. This is the PureStake information for their hackathon and all their sample code that they have. And so now I'm going to be talking to the PureStake indexer service. And when I go to run this, what we're going to do is just dig up some account information for this particular account. And this is, we're just getting started here, right? So once this runs, you can see there, hit my breakpoint, I'm going to hit go, and then down below, you should see the information appear in the console. And try it again here. All right. Continue on. There it is. Okay, so there's all the information now, about that particular account. Other code snippets, like here's one that I actually explained, right? I've got an asset ID, but I want to know, who search the accounts for who's got that particular asset ID. So once again, I'm going to go ahead and fire this off, and we will do this. Here it is, and now I've got an asset ID that's available, and we'll see it actually display here and come out on the bottom as well with that particular asset. Lots of capabilities. The one I really like quite a bit is you can actually search for a particular timestamp on an account for any transaction done at that time. This is great, if you need to verify indeed a transaction was made, at a certain time, and this will actually be looking for that particular, timestamp that you specify at -5 in the time zone, and there comes the information. So very, very cool stuff. And then the last demo I'm going to do here is I'm going to show you the rekey demo. Again, these are not really necessarily mainstream demos that a lot of folks will use on a regular basis, but when you do need it, you know, we've got samples to show you. And really what I'm going to show you in this particular demo is I'm going to rekey this. I'm going to have 3 accounts. So I'm going to rekey from account 3 to allow to sign from account 1. And then to prove it, I'm going to send money from account 3 to account 2, which is the one in the middle here, and sign it, but with account 1. So if you follow that, what I'm going to do here now is just run this, and I'm going to, not that one there. I'm going to stop that. I want to bring up the Python launch configuration. And there we go. So now I've got the payment that, and the way you do this is this additional parameter that says, okay, I'm going to rekey this to account 3, right? So I've got accounts that are listed down at the bottom of the screen. So right now, the sender is this FW, right, which is account 3 at the very bottom. And the rekey account is going to be this 43 account, which is account 1 up at the top. And so I'm just going to run this and, oh, geez. Oh, okay. I didn't reset this. So what happens here is it's saying I'm trying to make this transaction, but it's not authorized. That's because I already ran this one and I forgot to reset these accounts here at the top to do it fresh. But anyway, you get the idea. And the last step there was to go ahead and do that particular signing with using account 1. So it's really just that additional field on the transaction statements. So let's go back out to the deck and summarize and recap. So these are some resources. Once again, the GitHub, the Discord channel, good one to make a note of there. But good talking points with the growth of Algorand over the past year. All the different solutions that are out there, all the different accounts using it, and really all the fintech, that is engaged. Also, we gave you a nice set of slides here for the Algorand Layer 1 features, up to date now with the recent features as well. I drilled in a little bit into fast catch-up, rekeying, and indexer V2. We covered a lot of good reward programs and a lot of great tools and community resources, as well as lots of code.